Hello, it's Jay here again and welcome to another tutorial. So in this lesson we're going to pick up exactly where we left off in the previous video with the machine gun animation script. And in this video we're going to begin by coming straight below the void update, and we're going to say public void, and we'll give this a naming convention of play machine shoot animation. Technically it's not an animation, but it will act as such, so I think that naming convention will be fine for us. And we're going to define a new float as x, and we're going to say that equals a random dot range, open and close brackets, close the line off. Inside the brackets we're going to say camera original position dot x minus the position modifier, comma, and again camera original position dot x, but this time we're going to say plus the position modifier, and we're going to break that up for commenting, and we'll put it into the comments, and we'll say float x equals a random range between, and we'll say the camera's original position x-axis minus the position modifier, and we'll just copy that comment, we'll paste it in below, and we'll just add the word and to the beginning, so and the camera's original position plus the position modifier. And I'm sure you've guessed what we're going to do. We're going to copy that and we're going to paste it in twice more. And I suppose I should mention now, there are a number of ways to actually achieve this effect. No one way is right or wrong, but I've tried to do it in a way that's easy to understand and should work for everybody, so that's the way I'm doing it like this, but there are others. And I'm sure you've guessed, we're just going to, for this block, we're going to change x to y everywhere in the code. We'll also do the same in the comments, and the last one will change to z, and we'll also do so for the comments. Now we're going to come below, we'll create a line break, but we'll actually come back to this function and we'll create a new function. Now this can be of type private. We're going to say I enumerator, and we'll give this a naming convention of return to original position. We'll get both sets of brackets in place. Now don't worry about the red error, it's because we're not returning a value yet, but we'll come back to that. We're going to come into the previous function, and at the bottom here we're going to say start coroutine, open and close brackets, close the line off. inside the brackets 2 little speech marks, and we'll paste the name of that new function in the comments, and we can just say we're going to start that function. So start function, I'll just paste that in again. And now we can come to this block, this function. So the first thing we do is yield, return, and we want new, and wait 4 seconds. Open and close brackets, close the line off inside the brackets, underscore damp wait time. And yes, that naming convention will make sense in a moment, but for now let's get it into the comments. We'll say wait for the damp time. And as you can see, because now we return a value, which is this, through the wait for seconds function, we've got rid of that red error. We'll come below that line. Now we want the camera transform dot, and we're going to say local position. We're going to say equal to effect3 dot, and we want smooth damp. We'll open and close brackets, close the line off, and yeah, I think I'll break this up now because it's going to be quite a long line. So we'll break it up as we go this time. Camera transform dot local position, comma, camera original position, comma, and then we want ref and our underscore velocity, comma, smooth damp time times time dot delta time. So what we're doing, we're saying set the camera's transform, its local position. So let's get this into the comments. We'll say then set camera transform. We'll come to this next line, which just has the effect3 smooth damp, and I broke that up so we can put in the comments via the smooth damp from its current position to its original position and we can put by the velocity over the smooth damp time. So that is that function finished, and I'm going to come back here now. And so once we have the shoot effect in place and it's over, so we're no longer calling that function, it will slowly return to its original position. Well, I'll say slowly, it'll still be fairly quick, but it will be smooth. That's why we're using the smooth damp function. However, I feel like this function should be sharper. And we can achieve that quite simply by coming here. So I'm below the floats, but before the start call routine, and we're going to say underscore camera transform dot local position is equal to a new vector3, open and close brackets, close the line off, inside the brackets, x comma y comma z, and that is these floats here. So let's get that into the comments. Let's say actually set cameras transform to the new floats of X, Y and Z. And I think this is a good way of doing it because it shows you two different ways of actually setting transforms. So as you can, let's just quickly go over this. So we create 3 floats based on a random range between the camera's original position, which should also be its current position in this case before we've done anything, minus the position modifier, and then we use plus to get a decent range. We then snap to that position with this line, and then we call this function. When we call this function, we have a momentary pause, which is the damp time, and then we set the transform, but this time via smooth damp from its current position to its original, and via the velocity and damp time. So I hope you all understand it. It's still not finished. We'll still need some code in the other script, but we'll pick that up in the very next video. So as always, thank you for watching, and I will see you next time, and until then, bye for now.